This video presents a very simple example of uh, pointer arrays in C, and the example is taken from the textbook. So this example basically implements a program as follows. First, the program will get a sequence of strings from command line, and it stores it in this data structure. This data structure is basically an array of char stars. Here I have an array of 3 char stars. Each of those char stars or char pointers are pointing to an array, and the array is an array of character. So each char star points to a char array or a string. The first string, let's say the user enters is DEFGHI. The second one is JKFLMNOPQRST. And the last one is ABC. The next step, we're going to sort this array of strings alphabetically, and basically ABC comes first after sorting. The second one is DEFGHI, and the last one is JKLMNOPQRST. And at the very end of the program, we're going to print the sorted list of strings on the screen. All right, so let's take a look at how the program looks like. Let's assume that we have the definition of read lines function, write lines function, and qsort in a different place. I'll show you those functions later, but for now, let's say those are implemented. And I'll show you the main function. First of all, before I show you the main function, I just want to briefly tell you what each function does. The read lines basically receive up to n lines from a standard input, which is the keyboard, and store all of them in a char star array called line PTR. This is the same array that I showed you in the previous slide. The outline of this array is basically a sequence of char stars, each one pointing to a string. And the write line basically prints a given list of strings on the screen, and the last one, which is quicksort or qsort, basically grabs a list of, or gets a list of strings, a left and a right index, which basically specifies a subarray of that list, or a subarray of the array line PTR, and it sorts that subarray. The reason we pass left and right is because qsort is recursive. Those of you who know how quicksort works, basically it's a recursive sorting algorithm, and it needs to get the left and right index so that it always sorts the subarray starting from left and ending at right. And using that, we implement the qsort or quicksort in a recursive fashion. So those are the functions we call, but let's take a look at the main. In the main, first we are going to call the read lines and receive a sequence of, let's say, 3, 4, 10, 20, 100 lines from the standard input or keyboard. After that, we're going to call the quicksort on line PTR to sort all the lines. We're going to start from index 0, the left is 0, and the right is number of lines minus 1. That means I'm going to sort the whole array. And then after it's sorted, then I'm going to write all the lines on the screen using write lines, and that's it. Now, if the read lines ended up at an error, by an error, or if read lines return with an error, then it returns a negative number. Then we get to the else part and we print input too big to sort. I'll show you how read line returns a negative number. That's an exceptional case. But if that happens, we're going to print an error message on this screen, and that would be the end of this program. All right, now let's take a quick look at the readlines function, the body of readlines function. Here what we do is, in a while loop, we get a new line by calling getLine. That's a function that is used in the text box, but the more common way of getting a line is by calling a function called fgetS. That's much more common, but you know, we'll follow the book example. So getLine will get a new line, and the length of that line would be len. If the line is not received, or if there's no new line, this function returns 0, or I should say returns a non-positive value. And that's why we get out of the while loop, and we simply return the number of lines that has been successfully entered. But let's say the user wants to enter like 20 lines. So in the first 20 iteration of this while loop, this is going to be true. That means a line will be received from keyboard or from standard input. After you receive the line, it is going to be stored in line, where line is an array of length max len, where max len is 1000. That means you can have up to 999 characters. The reason I said 999 is because when the capacity of line array is 1000, the last one is reserved for a \0, which ends a string. So the number of actual characters in the string would be 999. So in any case, after you get the line, you check whether the number of lines is not exceeding the maximum number of lines that we have. That's a limit. That's just for the sake of practical reasons, and because we want to make sure that the user doesn't enter too many lines. And then if the number of lines exceeds the maximum, or the malloc cannot allocate more memory, let's say the memory is full, then we're going to return -1. And that's an error case. That's where in the main, if you remember, we print an error message on the screen. But these are not common situations. Like malloc always return a non-negative value unless there's no space in the heap. And by the way, in the book, instead of malloc, we use alloc, which is a function made up by the authors. And that's basically a simplified version of malloc. So whenever you see alloc, just replace it by malloc in your mind. Malloc means memory allocation function, which basically allocates memory in the heap. How much? This much. The length of the line, whatever the length of the line is, that's the number of bytes that we're going to allocate. In any case, after we allocated memory for the line that we just received from the keyboard, we are going to do this. First of all, getLine adds a new line at the end of the line, so we're going to get rid of it by doing this, by setting the index len -1 of the array line equal to 0. 0 basically is a sign for the end of the string. Then we're going to copy line into P. P is pointing to the heap because P is the return value of malloc, and we use a strcpy to copy the line into that space. And then what I have is this line, which basically copies the reference of the new line into the list of all the lines that we have, which is line ptr. That's the first input parameter of the function, and it's going to refer to all the lines that the user enters in order. from the oldest to the newest. And then at the end, I return the number of lines, and that's the whole body of read lines. Next, we have a very simple function, the read the write lines, which basically gets the area of char stars that I showed you and the number of lines. And in a for loop, it goes over all the elements of the line PTR array and prints them all using %s. So there's nothing special about this function. And next, we have the QSort. For those of you who don't know what QSort is a quick sort operation. I'll try to briefly explain it, but if you have taken, let's say, data structures, you know how it works. Let's say you have an area of, I'm going to show you the example of quick sort with numbers, not with strings, because it's easier. Let's say I have 10 here, I have 5 here, I have 7 here, I have 6 here, I have 2 here, I have 3 here, and I have 8 here. So what does this quick sort do? First, we pick a pivot. That pivot would be the middle element. Let me pick the pivot. That's called pivot, the middle element, which is 6. The next step after picking the pivot in a quick sort is to move everything less than pivot to the left side of pivot and move everything greater than pivot to the right side of the pivot. For example, this is in the left side of pivot and is greater than pivot. This is in the right side of pivot and it's less than pivot. So they should be swapped. So we're going to swap 10 and 2. After swapping 10 and 2, we have 2 here instead of 10 and 10 here instead of 2. Also 7 is greater than 6, but it's in the left side. 3 is less than 6, but it's in the right side. So we're going to swap 7 and 3. After doing this swap, 3 comes here and 7 comes here. So after reordering elements based on the pivot, which is 6, the array looks like this. We have 2 in the first cell, 5 in the second cell, 3 is in the third cell, 6 is in the middle cell. Then I have 10, 7, and 8. In the next level of recursion, quicksort is normally implemented recursively. We're gonna only focus on the left-hand side of pivot as a subarray and right-hand side of the pivot as a subarray. So you see this quicksort with the left and the right index that represents the range of, or the window that we're going to focus to sort in each function call, in each recursive function call. For example, here left is 0 because we started index 0 up to index 2. And in the other call, we start left at index 4 and right is at index 6. Again, for the left side, the pivot is 5. For the right side, the pivot is 7. We have to move 3 to the left side of pivot because 3 is less than 5. We need to move 10 to the right side of pivot because pivot is 7 and 10 is greater than 7. And after you're doing these reorderings and swaps, what you get is you get 2, 3, 5 left side, 6 in the middle, and the right side we have 7, 8, 10, and that's basically makes things sorted. That's how quicksort works, if I want to give you a very brief overview. So This quicksort uses a function called swap that swaps the ith index and jth index of array V. This quicksort is not sorting an array of integers, instead it sorts an array of char stars. And in C, when you want to compare two strings, you use strcmp. This is kind of similar to the string.char that one second. It is similar to a string compare to in Java. Basically, if two strings are equal, compare to was returning 0, same as this. strcmp returns 0. strcmp gets two parameters. If the first one is less than the second one, it returns a negative number, and if the first one is greater than the second one, that means if it's alphabetically after the second one, then it returns a positive number. So using strcmp and swap, which swaps two indices of the same array, we're going to write down the q-sort. Every time that you want to do a recursive function, you need to take care of the base case first. And the base case is where you have the smallest subarray possible, because as I told you, this q-sort each time sort a subarray. The subarray starts from left and ends at right. So the base case is when left is greater than or equal to right. That means you either have one element in your subarray or you have no element in your subarray. In that case, you don't need to sort it, just return, do nothing, because that's the base case. Base case means the subproblem is too small that you don't even need to call any function recursively. You don't need to do anything, just return. And then after that, after you take care of the base case, you need to start picking the pivot, which is at index left plus right over 2. You temporarily move pivot to the leftmost cell, and then you define a last, which is always pointing to the last element of the left subarray that we're gonna construct. And then starting from left plus 1 all the way to the end of the subarray, all the way to right, compare the ith element with the left. If it's less, we're gonna swap the ith element with the last plus 1 index. And then after this for loop ends, all the swap operation happens, and everything before last is less than pivot and everything after last is greater than pivot. We're going to move the pivot to the right location. We're going to do the correct appropriate position by swapping left and last. Then at this point, you have to call the function recursively. We call q-sort twice. The first time it's going to sort the left subarray, and the second time it's going to sort the right subarray, and that's it. That's the end of quicksort operation in C. It's a little bit too complicated because of the nature of quicksort. But if you want to use any quicksort operation, just copy this and use it in your project. You don't need to re-implement this. As you may have noticed, inside the q-sort we use swap, which swaps basically two indices i and j of the same array V. This is how the swap looks like. You need to first define a char star temp. Temp equals vi, vi equals vj, and vj equals temp. That's how the swap operation works. And that's going to be the end of this example. So as I showed you in this example, we had a program that gets a sequence of lines from standard input. It stores them in an array of char stars, and then it calls a quicksort on it, sorts the array of strings alphabetically using q-sort, and then eventually it prints them out on the screen. So on the screen you will see a sorted list of strings.